I only have 10 minutes, so this is kind of a teaser. If you have more interest into it, there is the annotations on Wednesday. So this is about our open semantic lab, Semantic Mediawiki stack we call Open Semantic Lab because it's for scientific purposes, because I'm actually also a material scientist and we want to store a lot of complex data. And this is about what we changed to what we changed in MediaWiki or in Semantic Mediawiki to better reflect our use cases. We want to build large knowledge graphs. This is what we want to do. And Jörn already provided this perfect introduction into the issue that nobody actually wants to draw triple by triple into this data set or make statement after statement on a person. So we want to have a pattern on that tells us this is a typical person pattern, it's a typical process pattern. You just need to fill out the mandatory fields and then you may add some additional ones. How can we achieve that was our question, and how can we then build our platform like something where you can put the patterns in, means to have a pattern in the form of a data schema and also the semantic annotations, maybe optionally, and then the platform transforms to anything what you want to have. If you have patterns to document your experiments, you have some electronic lab journal. If you have a pattern for a project, it becomes a project management tool and so on. I can also, there are good arguments why not store data in templates like we used to. And this is our concept, how we do it. That means that we use the multi-slots of MediaWiki stack to store different kind of informations. That means that basically every page has a JSON data slot where the structured data lies, so it's not very innovative, but data in a JSON data slot can be described by a JSON schema slot. And this is typically individual page is in a category, and the category page has then the schema that describes the JSON data slot of this individual. Kind of makes sense. So if something is in the category of a person, then it also should comply to the schema of a person. And more, we can even, of course, then build our class hierarchies, and then we inherit also the schema. So a user is maybe a person who has additionally username, means that the schema of user is slightly extending the person's schema, as the category is a little bit more specific. And we can also, this is great, it's also very useful, we can also model classes with meta classes. We can also have kind of categories of categories to build them more easily or to sort them additionally. And of course we need to think visually, so we can of course use templates as we used to, so we can feed all the structured data also in the main slot where we can have usual MediaWiki templates. And we can also came around with embedding MediaWiki templates, or also lighter mustache templates in the JSON schema, meaning that if you have a very nested, let's say, GPS coordination, and you want to display a map, you just have this evaluation template that renders this map with MediaWiki parser functions. But this is in the schema without invalidating the schema as a JSON schema, but our parser then would place this map in the info box and not the bar coordinates, for example. But you can then place the templates on the data where they are really needed and not on a very other position. And of course, then it's also easy to use page exchange, for example, to be bundled and a lot of the schemas to make them shareable in our instances. We also thought about how relates this to other existing technologies, and of course people like programming and they like to build their classes in Python, Pydantic, and other people like knowledge graphs, so they think in RDF and shackle shapes in OWL, and I think there is some good connection in between, and this is what we call the OOLD schema. This is basically the idea that we have JSON in the center, of course, and we have JSON schema describing the structure of our JSON, and this gives us access to arbitrary set of tools. For example, you can generate open API endpoints we can generate Python classes. We can, most important for us, generate HTML forms. And we can also put JSON-LD on that. So we have RDF, or we can also use JSON-LD, of course, to generate Semantic Mediawiki property annotations by using actually format that is well understood outside MediaWiki, because it's not specific, but we can interpret it with our Semantic Mediawiki stack. We can render it with our existing templates. But if you put the data to somebody else, he can also use it directly. Yeah, you can. This is our growing formal description, but the basic minimalistic schema would look like that. You would have the JSON schema part telling a person is an object in a technical sense. It has a name property, and name maps to schema org name. So it's the syntactical shape and the semantic meaning of this properties into one container, and you can then build a complex hierarchy and refer to external definitions, etc. And here's a little playground. Looks complicated, but on the left side is the schema itself. And here you see the form that is generated, and this is completely fully automated. So if you would modify your schema to provide another field, then of course, because it's fully automated, you will get your new rendering instantly. So you have additional H field if you need it. But anyway, the user can then manipulate the data. He gets structured output here all in YAML for readability. And the context can be used to generate actual triples by the JSON-LD standard. So at the end, you will have this bunch of RDF if you're interested into seeing it, but typically you maybe store it just on a triple store and forget about that. So the user has his tools, and this tool makes everything in the background. And if you are a programmer, you can do the same with Python. So we just replace the form slot here with a Python viewer, and then you see this is the class hierarchy you would get in Python. But then you can, as a programmer, you can generate the same data, which exports to the same RDF by using the exact same schema definition as a base. Okay, this was maybe a little bit theoretical. Of course, we use this in production, and you typically have a lot of categories, and every category in the system has a schema. That means also you can click on any category here, and it will render a form. So this form is completely based on the project schema of a project. And as I said, so you have the actually fields that we find necessary, and of course there is a autocomplete feature that queries the knowledge graph behind. For example, existing organizational units are listed, so you can find existing properties. Yeah, so this all we get. So we write our schemas, they store the data, they render the data, and they auto-generate user interfaces for them, and they can also auto-generate code to make everything programmatically. And also as an extension to the usual forms we know, we can of course build also very complex ones. For example, here you have samples in a nested form, and each sample has properties. Then you can assign tasks to samples. So tasks is another nested structure, and in the nested structure there's maybe a reference to the sample that was used, and here you can then pick the samples you already defined. So you can really build very complex nested structures if you need them. And the final point I want to come to in this short intro is the fact that another useful application pops up, and this is large language models. Reason added feature is structured output, meaning you provide, one can guess, a JSON schema and ask the LLM for completion. So you say, here's some information, please try to complete a schema. And it means that we can feed any category, any form we have to the LLM and ask for assistant. And this is assistance, and this is of course pretty neat. For example, you want to create an organization. Here's the class, and then typically you need to look up all the information about, for example, Fraunhofer. But it is easier, of course, because Fraunhofer is quite in the knowledge of the LLM already encoded. You can just write Fraunhofer, and then you click on AI completion, meaning that we feed the schema, the existing filled out form fields, to the LLM, and it will write a description for us, also in multiple languages, provide an address and a link, all in a few seconds. And this works for every category write without any additional tools, because it's all very generic implemented. Just as another example, we can have, for example, we have a publication. You want to store a PDF abstract in your system, and you may have just the PDF. So this is then a file attachment. So typically PDF abstract, so there's no structure in it. There is some names and some text, obviously, maybe some references. And then you just say, okay, there's a paper, and here's the PDF. And then, of course, the same thing happens, but additionally, the PDF is, of course, extracted as text, and this is also fed into context. And then this context is also used to answer the question, what is, for example, a list of authors here. Okay, in this case, it makes something different. I expected, so it tries to get some statements, but it depends on the degrees of freedom in your schema, what actually is then created. Yeah. But at the end, we also have, of course, the feature that you look up. If you find a name and the name is on a knowledge base, it can also look up then the name and find the right identifier, for example. So now we have here the author list as expected, and it's not, it's putting the name of Simon Stier, for example, here, and the loading time is a little bit slow, but it will also fetch the right ID of this name and store this ID. So you also can link to existing objects. Okay, yeah, that's it. I think this is a short overview what we get if you stick to external well-used standards, and how it really can speed up things by software automation and data automation, and also helps with LLMs because it really uses only the very specific information that is helpful for the LLM, and not providing tons of PDFs that mostly are not relevant for completion form. Thank you. Yeah.
Maybe one question due to the time limit.
One question. I have one question. Where do you store the data and how?
Yeah, so all data is stored in this, in a slot. So we have the slots, and the JSON data slot contains all the data.
All the data. Have you ever thought, because I have a similar setup, but I decided that I don't want, because it can be lots of data, and perhaps you can have external data. Do you have, is all the data from people within the organization, let's say, safe, or do other people, can other people add data at some time? Can you publish a form to the world and that you can gather data from outside? And if you do, then you probably wouldn't want to store the data in slots, but in an external data store.
Yeah, I mean, basically this forms just generate JSON, and or JSON LD precisely, and where you store this is then you can provide any backend that's capable to store JSON, and this is also for us important. I mean, Semantic Mediawiki is a nice stack, but if you really have a high data scenario, it's much too slow. So if you maybe skip all the visualization and the user interface, And of course, there are more performant backends, like a simple document store that just you throw the data in. But I think it's important that Wikibase has this, as already said, they separate the data editor very much from the usually wiki interface. And there are some bots that shuffle data from the one side to the another one. And here I think it's nice to have it integrated so you can have a well-guided and structured form to edit the data. But if you directly get a proper visualization of it. So there's no, it would be like Wikipedia and Wikidata really merged into the same user interface.
Okay, thank you, Simon.